Hi guys, myself Manoj.M. In this video, let us solve this problem. Practice problem 3.3. We need to find the V and I. That means voltage and current in the circuit of figure 3.11. Yeah, right? Yeah, guys, in this video, let us find the V. That means the voltage across the 3 ohm resistor and I current through the 2 ohm resistor. In this, we need to apply that supernode. Okay, so a supernode is formed when voltage source connected to non-reference nodes. That means non-ground nodes. Here it is not connected to ground anywhere else. So that we apply supernode. Okay, let we make this to ground. V is equal to 0. Let us consider this as A and this as B. Okay, and here it is 14 volt. Okay, because there is no loss of voltage, right? There is no resistor. That means it will become 14 volt here. Okay, here this one also, this is also B. Okay, because there is no resistor present here. Okay, yeah, right. Yeah, let us write the circuit after the apply of supernode. We apply supernode to this A and B. Okay, this one. For this, okay, yeah. Here the current is entering in this way and the current is leaving in this way, and here it is and here in this way. Okay, for the supernode A and B, the current entering here is this one only. Here it is. Write the circuit. After we apply the supernode, I will write it here plus minus. Okay, and then this one is 4 ohm. Okay, here this is 14 volt. This one, and here it is 3 ohm. Okay, 3 ohm plus or minus volt current direction. Yeah, here it is A. Okay, and from A to B there is no need to write this voltage. Okay, simply write like this. Okay, this one is B, and here the 2 ohm resistor, and then it will come here. Okay, here we make the ground of it. V is equal to 0. This is 2 ohm. The current is I, and then it is B, right? And here it is 6 ohm, right? Resistor, yeah. Then connect here to here. This is 6 ohm current in this way, right? Yeah, right? Yeah, let us apply KCL at the supernode AB. Okay. Here it is also this one 14 volt. Okay. Let us apply KCL at the supernode AB. Apply KCL at supernode AB. Okay, yeah. Let us apply KCL. We know that the Kirchhoff current law states that the sum of current entering the node is equal to the sum of current leaving the node, right? Yeah. Here the current entering is this one. Yeah, let's mention here also 14 minus VA divided by 4. Okay. Yeah, I will write it here. 14 minus VA divided by 4 is equal to, yeah, I will slightly move this above. VA minus 0 by 3, that is VA by 3. Okay, here write VA by 3 and then plus VB by 2. Okay, VB by 2 and then VB by 6. Okay, plus VB by 6. Okay. Yeah, we know that we need to make this denominator as 1. For that, multiply it by 12. Okay. Yeah. Here we know that 4 3s are 12. 14 3s are is 42. And then minus 3 VA is equal to here. Then here 3 4s are 12. And then it will become 4 VA, right? And then write plus. Okay, here 2 6 are 12, it will become 6 VB, and then 6 2s are 12, it will become 2 VB. Okay, yeah. And then move this minus 3VA to this side. Okay, 4VA plus 3VA plus 6VB plus 2VB is equal to 42. 4 plus 3 is 7, right? 7VA plus 6 plus 2 is 8, right? 8VB is equal to 42. Let us consider this as equation 1. We need another equation to find VA and VB, right? For that, let us move this here. Let us see this circuit. Here it is VB minus VA is equal to 6 volt, right? Yeah, write that here. I will write it here. VB minus VA is equal to 6, right? Here we can write it as minus VA plus VB is equal to 6. Okay, let us consider this as equation 2, and then I will open the calculator to solve this equation. Yeah, and then click on mode setup, then click on 5, then it is in the form of ANX plus BNY is equal to C, and click on 1. Here it is 7 and then 8 and then it is 42. Okay, and here it is minus 1 and then it is 1 and then it is 6. Okay, and then click on equals, then yesterday here VA came as minus 0.4 volt, right? VA is equal to minus 0.4 volt. It minus 0.4 volt K is equal to minus 400 millivolt. Okay, and then let us write the VB here. VB is equal to, I will open the calculator and click on equals, it will equal to 5.6 volt, right? 5.6 volt here. Yeah, you have the doubt, right? How it minus 0.4 volt become minus 400 millivolt. I will open the calculator to show you this. Then click on mode setup, then click on 1. Here minus 0.4, then click on equals, then study, then click on shift, then click on ink. It will show minus 0.4 into 10 power 0. Then again click on ink. It will show minus 400 into 10 power minus 3. We know that 10 power minus 3 is milli, right? That's why I write like this. Okay, I hope you understand why I write that. Okay, yeah. And then, yeah, we have to find the I. Already we have find the voltages. The voltages through the 3 ohm resistor. That means VA is equal to V. Okay, right? V here. Okay. And then we need to find the I, right? What is I? That means the current through the 2 ohm resistor, right? We know that V is equal to IR. I is equal to V by R. For that we write I is equal to VB by R. Okay, right? I equal to VB by R. Okay, VB is 5.6. R is 2 ohm, right? Yeah, right, 2 ohm. Okay, is divided by 2. That will become 2.8 amps. Okay, we know that the SI unit of current is amps, right? V is equal to minus 400 millivolt and I equal to 2.8 amps. Okay, and then I will put a box to this one. That's it, guys. I hope you understand how I solve this problem. If you have any doubt, you can comment in comment section. If you didn't subscribe my channel, please subscribe my channel and hit the bell icon. Thank you for watching, guys.